Okay, let's look at square roots. A square root is the inverse of squaring something. So for example, the square root of 9 is 3. And that's because 9 equals 3 squared. So when you're trying to find a square root of a number, it's really asking what number squared would give you that number. Because 3 squared equals 9, the square root of 9 is 3. So let's look at some more. Square root of 16 is 4. And that's because 16 equals 4 squared. And the square root of 25 equals 5. Because 25 equals 5 squared. And you probably already know these. If not, it's okay. Just ask yourself, you need to know the square root of a number. What number squared would equal that number? But let's look at something a little bit more complicated. The square root of fractions. We want to know the square root of 4/9. This might seem difficult at first, but all we have to do is do the square root of the numerator and denominator individually. So we have the square root of 4 over the square root of 9. And the square root of 4 is 2. Square root of 9 is 3. So this all equals 2/3. Also, we have the square root of 16 over 25. Same thing. We'll just do the square root of the numerator and the square root of the denominator separately. So the square root of 16 over square root of 25, and this would equal 4/5. Okay, now I told you in the beginning that square root is the inverse of squaring something. So this is going to come in handy in algebra when we have something like x squared equals 25. We want to find out what x equals, so we have to get rid of this squared up here. So we have to do the inverse of squaring x, which would be to do the square root of it. And of course, whatever you do to one side of the equal sign, is to do the other. So the square root of x squared more or less gets rid of that, the 2, the squaring it. So we're just left with x. And the square root of 25 is 5. So we see that if x squared equals 25, then x must equal 5.